Assalamualaikum and hi guys. So, as a conclusion, there are several factors that you have to consider to identify whether the reactions is undergo SN1 or SN2 mechanism. Okay, so basically you have to identify what is your Rx, like I showed you before. So what is your reagents? It is a nucleophile, it is a strong nucleophile, or it is a weak nucleophile. And then what is your synthesized products? So basically, like this one, okay. So for this one, for example, you can check your product is OH located at your first carbon or located at your primary carbon. So your next carbon is more stable than your first carbon, but there is no rearrangement. So meaning that this is SN2 reactions. So what is your reagent? It is a OH negative because SN2 needs a strong nucleophile. Why I don't using another strong nucleophile such as SH negative, such as I negative. Okay, why? Because of the product is OH. So that's why I need to use OH negative. And then what is your Rx? You can draw this structure. So this is your structure. CH3 and then CH3 and then you have CH2 and then you have H. So with the I, for example, any halide group. So this is your starting materials. Okay, so ingat kelas, bukan saja you kena tahu Rx tambah something dapat products, you juga kena tahu reverse fractions. From product, how to predict you punya starting materials and you punya reagents. Okay, so this is basically summary on reactions that will occur based on the halide group, type of halide group. So if it is a methyl halide or primary alkyl halide, so no matter how, if it is a strong nucleophile, only SN2. If weak nucleophile, there is no reactions. Okay, it will go for the elimination reactions if the base is a strong base. If weak base, so meaning that there is no reactions. For the secondary, so you can see strong nucleophile with a protic, so SN2. Strong nucleophile with a protic solutions, no reaction, sorry. So it will go for elimination reactions. And bila secondary, you ada weak nucleophile, protic ke tetap SN1. Okay, and then you have the tertiary alkyl halide. So strong nucleophile dia akan pergi ke elimination sebab tertiary alkyl halide tak boleh berlaku SN2 because of the steric hindrance. So if dia adalah weak nucleophile, so dia akan go for SN1 reactions. That one is the summary. And then this is a summary for the whole reactions. You can see, so substrate for SN2 is a methyl or primary or secondary, tertiary not suitable, and other properties that we have been discussed before. Alright, so this is some exercises. Okay, so the first one is a SN2. Why? Because this is primary alkyl halide. So methyl alkyl halide and methyl halide and primary alkyl halide memang definitely SN2. So for the second one, if you can see, the Br is attached to the tertiary alkyl halide. So for substitution reactions, tertiary alkyl halide, it is a SN2 reaction. SN1 reactions. Okay, so I just want to emphasize the characteristic. Okay, here for the type of substrate, nucleophile, solvent, living group, rate of reactions, stereochemistry, and rearrangements. All of these you can use to differentiate whether the reaction is SN1 or SN2. For example, if the substrate is a methyl halide or primary, so definitely it is for SN2 reactions. But if the alkyl halide is a secondary or tertiary, so maybe it is a SN1 if the Rx is a secondary, or it could be also for SN2 reaction if it is secondary. But for tertiary, is definitely SN1. For SN2, require or need strong nucleophile. SN1 will need weak nucleophile. For solvent, polar aprotic. So SN1 is polar protic. Living group, both SN1 and SN2 prefer good living group. And then stereochemistry, it depends. For SN2 only inversions. For SN1 is retentions and inversions. Rate of reactions we already discussed. So this is the rate equations. If the questions ask you to write uh, the rate equations, so this is the rate of equation for SN2 and this one is for SN1. And then for stereochemistry, inversions, this one is retentions and inversions. For rearrangement, SN2, no rearrangement. SN1 have rearrangement, depends on conditions, whether it is an SN2, whether it is an hydride shift or metal shift. So that's all untuk substitution reactions SN2 and SN1. Thank you guys.